Hello, and welcome to How to Determine the Type of Intermolecular Force with me, Miss White. Hey guys, so I was hoping to give you, I thought you might get a little confused. I'm on the back of the worksheet. I'm going to go over something to help you with that, and then I will do I'll do one as like an example with you, and then I want you to try the rest. So the first thing you need to figure out is if the molecule is polar or nonpolar. Okay, and that's what we've been working on recently. So remember, you're going to have to draw how to figure this out. You draw your Lewis structure. You figure out if the bonds are polar or nonpolar. If the bonds are nonpolar, the molecule is nonpolar. If the bonds are polar, that's where you have to look at the geometry and see whether or not the dipoles cancel. And if they do cancel, then the molecule is nonpolar. If they don't cancel, then it is polar. Again, you have notes on that, your molecular polarity notes, and that's what we have been practicing, so you should be good with that. So if the molecule is nonpolar, okay, then it's going to have London forces. All right, all molecules have London forces, but in nonpolar molecules, London is the strongest force, right? And we're looking at picking out the strongest force because really that's what's going to determine different things like boiling point and how it interacts. Now, if it's polar, the next thing you want to look and see is hydrogen bonded to nitrogen, oxygen, or fluorine. Okay, so again, if you figure out the molecule's polar, you look and see if there's hydrogen. Hydrogen has to be bonded to nitrogen, oxygen, or fluorine. If the answer is yes, okay, then that tells you that it's hydrogen bonding is your strongest intermolecular force. If the answer is no, okay, then that tells you that it's dipole-dipole. Okay, so again, use this little flow chart. So let's do where it says list the strongest force. So the first one is if we have two molecules of methane or CH4 together. Okay, so I'm going to go up here. I need to figure out, is it polar or nonpolar? So I'm going to look at a CH bond, okay, and the electronegativity difference between those two is 0.4, which means the bonds are nonpolar. If all the bonds are nonpolar, that means the molecule is also nonpolar. Maybe I should go over here, okay? So we have a nonpolar molecule, right? And remember, we figured that out because all of the bonds were nonpolar. So this molecule is nonpolar. So we go up here, polar, nonpolar. That means the strongest force holding together these two molecules is going to be London. Okay? So again, that should help you with the rest of these. Do the best that you can. We will be going over all this stuff, but I want you to try your best and complete all of these, and then we will check them next time. Hope you're having a good day. Okay, bye.